Hi everyone, this is Digitalk with Bimulus. The purpose of this podcast is to raise built environment digitalization awareness amongst industry, showcase Singapore's efforts on built environment digitalization such as BIM, IDD and IPD, and look at digitalization worldview through the lens of Singapore. Every month of the last Friday, we'll be inviting guests to discuss the latest BIM trends happening in the world. We look forward to you following our podcast. Thank you. Hey, great. Afternoon to you, Adam. Thanks for joining us on this podcast. Hi, everyone. Today we have Adam Jordan from Bryden Wood, whom is the Asia Pacific lead with a wealth of experience in DfMA, both in Singapore and in Australia. So he's gonna give a bit of short introduction as to what DfMA is all about. I hand it over to you, Adam, to give a short introduction about yourself.
Thanks, Chris, and thanks for inviting me onto the series. It's good to be here. So my name's Adam Jordan. I'm the Asia Pacific lead at Bryden Wood. Bryden Wood are an international consultancy of architects, engineers, multidisciplinary, so covering civil, structural, mechanical, electrical engineering, as well as other allied disciplines like some software people and programmers, analysts, construction works planners, people from all sorts of backgrounds coming together to help improve productivity, efficiency, and value in the built environment. So we've been working for 30 plus years on projects of all sizes in all sectors, trying to deliver better results and outcomes for clients and for the community by applying innovative construction methods, digital technologies, and innovation to improve on conventional construction methodologies and conventional design. So my background's architecture, and I studied in Australia, so I'm originally from Australia. I went over to the UK for a gap year kind of after university. Before I kind of settled down and got a proper job, I'd go and get a little bit of international experience. So I went over to London, joined Bryden Wood, and found myself spending 10 years with Bryden Wood in the UK, and then moving with Bryden Wood to Singapore in 2015 to set up our Singapore office. So in Bryden Wood, we work with all sorts of clients, from small private companies to large multinational corporations. And one of those corporations, GlaxoSmithKline, the pharmaceutical company, kind of brought us to Singapore. Effectively, we were working on their capital projects around the world, and they had a lot of investments happening in Asia Pacific. So we thought it was prudent to open an office in Singapore. At that time, was an exciting market from a DfMA perspective because BCA, the Building Construction Authority, just beginning to kind of embark on a DfMA strategy and trying to kind of spearhead adoption of DfMA in the region in Singapore. So for us, it was a good time to set up there. And so now we have 12 people in Singapore, a small team, but a good regional hub for some of the work that we're doing. Then I guess kind of just at the right time before the world shut down in the pandemic, I started spending a bit more time back home in Australia again, and ended up back in Australia during COVID time, running the business remotely. I work in Singapore, and also looking for opportunities, starting to look for opportunities here in Australia to introduce Bryden Wood. And so I stuck around in Australia after the pandemic concluded, and now I'm based here in Sydney, together with colleagues in Melbourne. We have 2 offices in Australia, and we incorporated last year in Sydney and Melbourne. So together with my colleagues in Singapore, we're a little Asia Pacific team, and working as part of the global Bryden Wood business, trying to introduce DfMA and improve construction outcomes for clients around the world.
Great, thanks for that introduction. So we talked about DfMA, and we all understand that DfMA is short for Design for Manufacturing and Assembly. So what is it that Bryden Wood does with DfMA? Could you just explain a bit?
I hope that most people listening on the podcast will be familiar with DfMA, and I think as an industry we don't do ourselves a lot of favors sometimes in terms of all the naming, because it can be quite confusing even for someone who's working really closely as part of the sector. We have all these names and acronyms. I know that everyone in Singapore loves acronyms, so it's probably quite used to abbreviating things into a few letters. But for me, certainly I find it quite confusing. And we have DfMA and MMC and PPVC, and in Hong Kong they have MIC, and we have all these. And then people talk about DfMA is designed for manufacturing and assembly, and people have now started talking about design for manufacturing and disassembly, which is DfMA-D. And then in Bryden Wood, we're also talking about platform approaches to DfMA, which is P-DfMA. And I guess if you then disassemble it, it could be P-DfMA. It's just it can be a bit overwhelming sometimes. We don't do ourselves a lot of favors. So I'll explain my theory about how all this breaks down a little bit. DfMA is a design activity. So the clue is in the name. I like to get away from the acronyms a little bit and focus on the names. And so DfMA is design for manufacture and assembly. So that as a design activity, it should be carried out by designers. So Bryden Wood are designers, architects, engineers. We approach a building, a project, a client brief as a design challenge that should be solved through a design process. But a DfMA design process is different to a normal design process, because from the very beginning of a project, we consider how the project is going to be put together. And we have some tools at our disposal, so we can consider how a building will be put together, or a piece of infrastructure. It doesn't have to be a building. Leveraging on the benefits that are made possible by manufacturing of parts of the building in a controlled factory environment, and the efficient and productive assembly of those parts. So trying to take construction sites away from being kind of sometimes a bit of a messy, chaotic kind of work front to being more of like a factory style assembly methodology. So thinking about how buildings go together from the earlier stages and how best we can design buildings to go together efficiently is kind of what Bryden Wood is all about. And ultimately, a client investing in a project is spending their own capital to deliver an outcome. And it's our role as designers to make sure that they can achieve that outcome as efficiently and as cost effectively as possible to get the best value from their expenditure. So for us, it's a focus on value. We like to say in Bryden Wood, our focus is design to value, because everything we do as designers is to try and achieve clients' functional requirements in the most cost-effective, efficient, and productive way. So DfMA is a design activity. MMC, modern methods of construction, this kind of refers to the tools and techniques and processes that exist that are different from conventional construction. So PPVC in Singapore, prefabricated, pre-finished volumetric construction, is a form of MMC. In Hong Kong, MIC, modular integrated construction, also similar to PPVC. This is a 3D volumetric prefabricated solution, is a form of MMC. And a flat pack panel, or a precast slab, or a 3D printed prefabricated element, or a prefabricated MEP riser. These are all examples of MMC, right? So MMC is a little bit of an umbrella term. And as designers following a DfMA process, we can use MMC as kind of our toolkit. So we have all of these opportunities available to us, all these tools and techniques and processes that we can draw on to deliver better buildings. So all of these processes, all of these tools and techniques are about designing buildings that can be built more efficiently, productively, to deliver better value for clients. But one thing I think that all of this is focused on so far is taking projects at an individual level. So treating every project as a one-off unique solution. So DfMA as a process tends to add more value through repeat use. So if you design a project in a DfMA way, you're developing a construction methodology. Sometimes that is a little bit more upfront investment in thinking about the methodology, finding the best solution, doing the prototyping and the testing and the validating and going through an approvals process to get that solution up and running and delivered on the scheme. Once it's delivered on the scheme, if you then kind of walk away and move on to do something else, then all of that effort, that upfront investment is lost. So we want to work on projects where DfMA delivers maximum value through repeat application. This means frameworks. It also potentially means finding standardized solutions that cross between multiple frameworks that are compatible to deliver different types of buildings using the same component kits of parts at scale. And so this is where P-DfMA comes in. So platform approach to DfMA is about saying there's a lot of similarity between different types of buildings. There's a lot of difference too. So if we can find standard kits of parts that have the capability of delivering a large proportion of multiple different types of buildings with the potential to be flexible and customizable in the right ways to deliver quality architecture, then with standardization at its heart, then we have an opportunity to unlock real value, to lower the barrier of entry to supply chain, to create a large pipeline of work for the industry to grow, and really transform the construction sector. So a lot of our most recent thinking at Bryden Wood is exploring not just DfMA at a project level, but P-DfMA at a framework level and beyond, to try and find the real opportunities to transform construction as an industry.
So, it's great that we can find solutions or standardized solutions to a variety of designs, whether you're doing an office, whether you're doing a factory, whether you're doing a school or a hospital. Throughout your experience, in Bryden Wood, did you find any in a situation where it becomes a constraint to the design because of the modular concept that has to come in for DfMA? Were there any constraints?
So DfMA should never be about imposing constraints on a project. I think if, as a client, you have a goal, you have a functional requirement for a brief that needs to be delivered. As soon as the constructible approach compromises those requirements, you're kind of going down the wrong path. So you talk about modular. So when you talk about modular, I'm thinking about volumetric 3D solution like a PPVC, prefabricated, pre-finished volumetric construction solution. And this technology is applicable and can deliver really successful outcomes in some applications. So let's take a hotel, for example. There's a quite famous project in Singapore, Crown Plaza at Changi Airport is a good example, I think, of where PPVC was used effectively. So a very highly constrained site in the middle of one of the world's busiest airports, and a highly standardized, repeatable design of hotel rooms, which were perfectly sized to suit transportation requirements on the roads, could be prefabricated in a very standard way and lifted into position with a crane. And that building went up very, very quickly. It was quite a successful project delivery. So there are applications where this type of 3D modular construction can work really well without compromising the design. It's still a very successful hotel. But in a lot of applications, this type of technology isn't really appropriate, we think. So it might not give the best design outcomes. So you talked about hospitals and schools. We can talk about offices and residential spaces. Now, PPVC 3D volumetric modular construction is not always very good for offices, for example. Offices tend to work to a 9 meter by 9 meter, more or less, kind of floor plate to suit rows of desks with circulation space in between. So to deliver large, clear spans that office commercial corporate clients need, you need to think outside the box in terms of the construction solution. So for us, a solution to deliver an office floor plate in a prefabricated way might not be a 3D volumetric way. So our platform approach is really founded on finding a kit of parts of construction components that can deliver such a space quickly and effectively and efficiently. So we've developed, for example, a kit of parts solution for commercial space such as this, which we've rolled out in the UK actually quite successfully. A recent project that has just been completed called The Forge, quite a high profile project. There's lots of information published online about this project. And this project comprises a quite simple set of prefabricated parts, encompassing both permanent works and temporary works. So these parts are designed to be quite simple to fabricate so that the widest possible supply chain is capable of providing them. Some prefabricated steel shuttering tables that are reusable. So these are temporary shuttering elements that you can erect and then disassemble and reassemble, and they kind of move up the floors as the building goes up. Some temporary props to hold those up in place that are also disassemblable and reusable. Some downstand beams, which are folded steel trays, which are an off-the-shelf solution that become kind of permanent formwork for downstands. And steel columns that are kind of stop sections with some plates welded to them, and then some bracketry, which is a little bit more customizable, but pretty quick to fabricate in large quantities. And these components go together in a very simple way so that a very small number of people can do it on site in quite a short amount of time. Everything is done at low level, no working at height, no need for heavy lifting equipment. Everything is quite light and manhandleable. And then all of this enables an efficient in situ concrete pour. So we kind of looked at using precast panels. And in the case of this project, we thought we can actually get better structural performance out of an in situ pour. And we can transport concrete much more efficiently in dense inner city urban locations using an in situ concrete pour. And then everything that we do is in the erection of the system is geared around making that pouring operation as quick as possible using disassemblable temporary works and some permanent shuttering elements and permanent structural elements with no waste, no sacrificial works, no wasted labor, very focused, very highly productive site labor, and no reliance on a tower crane. So that tower crane can then be redirected to installing facade. So we developed this system not geared around the maximum amount of pre-manufactured value, the maximum amount of off-site prefab, but the most efficient overall construction process where factories and the construction site are working together very efficiently in perfect harmony. And for us, this is what the future of construction looks like.
And there has always been this understanding or misunderstanding between the differences between DfMA and PPVC that you have talked about, right? Is there a distinct difference between the two? Because after all, PPVC has also kits of parts that are modular. They are then assembled as a PPVC. So what's your take on this, between the two?
So as I said, PPVC is a form of MMC. It's one of the modern methods of construction that you can use in a DfMA design process. So PPVC is a possible solution that is a DfMA solution, but it's not the only solution. It's not a one-size-fits-all solution. So PPVC is very applicable and can deliver a lot of benefits in some circumstances. So a hotel project, for example, might be perfectly suited to PPVC, where you can do most of the construction works in a factory in a highly standardized, efficient way, and then the on-site construction becomes very, very simple. Another example of a project where PPVC might be considered is for an area of a project that is very heavily serviced or quite a complex part of a building. So for example, wet areas, so toilets, are quite a popular use of PPVC, and in Singapore, that's called PBU. or prefabricated bathroom unit. A prefabricated, pre-finished bathroom module can take a lot of plumbing works off-site, a lot of wet works off-site, decongest trade interfaces on site, and make the construction site work more efficiently, allowing also plumbing works to be pre-tested and pre-commissioned so that there's less defects, less quality issues happening on site. Other elements that are heavily serviced could include plant rooms. So pre-packaged plant rooms, which contain, for example, substations or electrical equipment that's been installed, pre-tested, pre-commissioned, tested to ensure quality, and then packaged up and transported to site and kind of plug and play, can really decongest critical bottlenecks on construction projects. So areas that are complex, that have a lot of trade interfaces, have a lot of challenging works, or potentially have a high degree of finishes or fit out requirements, lend themselves to PPVC very well. Areas that are larger in span and or simpler in terms of their accommodation don't deliver as much value by prefabricating and pre-finishing them. So we would, so for example, an apartment block, let's take an apartment block, for example, in Singapore has some successful examples of apartment blocks that have been prefabricated using a PPVC approach. But for us, when we look at an apartment block, we see some areas of high complexity. So kitchens and bathrooms, particularly the wet areas, where there's a high degree of finishes and fit out required as well, and a high degree of quality required in waterproofing, for example. And then we see a lot of areas of quite low complexity. So I'm in my apartment here, we have a couple of bedrooms, we have a living area. These spaces are quite simple. There's some carpet on the floor, some paint on the walls, and a few electrical switches. There's not a lot of complexity there, so it doesn't take a lot of effort on site to finish these kind of areas. Pre-finishing these areas in a factory doesn't add much value, but what it does require is transportation of a large volume of air and all that structure through the streets. It does require a lot of lifting. It does require a lot of structural considerations of integrity and the temporary state of lifting and transportation. It adds a lot of complexity without really removing complexity from the site. So I see a solution for a residential building being a combination of potentially PPVC areas in the complex parts where you have kitchens and bathrooms with high fit out requirements and all the other challenges that we've talked about, and maybe another type of construction like a panelized system or even a combination of in situ and prefabricated works for the simpler parts of the project where the level of finishes and fit out requirement is not very high. So PPVC is part of DfMA for sure, but it's not the only part.
And we with DfMA, of course, it comes with standardizations of parts because they need to be modular. Then if there's standardization, then what about helping to standardize these components when you're fabricating it? Does automation comes into play? Because all these kits of parts has to be prefabricated offsite before they actually get delivered onto the construction site. So what are the things that is involved in the automation for this kind of fabrication for standardized parts?
So we try and make the majority of prefabricated parts as simple to prefabricate as possible, because part of DfMA is making factories work efficiently. So if you have a construction project and you convert it into a prefabricated solution, which requires a high degree of factory complexity, you make it very hard for factories to do the job. So it means that you have a very restricted supply chain because you need factories that are extremely capable and have advanced machinery in those factories. And therefore you make the project quite expensive because there's very comparatively few parties that can really do the work. So if you have simple prefabricated components for the most part, then you lower the barrier of entry. It means that more factories can do the work, more factories have that capability, and you make the project cheaper, and you can source elements from a much broader supply chain, getting much more competitive quotes. So we always try and design a structure to be efficient and to use simple elements that are available from the market. So a certain amount of analysis of what existing solutions are already out there on the market is really important to help steer this kind of decision making. Standardization is important, but I would say should be considered as well. So standardizing everything so there's only one kind of option for every part of a building is quite restricting from a design perspective. And we want to ensure that designs have standardization, but also customization, so that you can deliver different forms, different massing, different finishes, different styles, suit site-specific requirements of projects using as standardized an approach as possible, but with customizable elements. That means you might say 80% of the building is standardized and 20% of it is site-specific. It might mean that for some elements you have not just one standard type, but maybe a few different variants of a type. So you might have a few different iterations of length or width of a component. Those lengths and widths should be sized based upon available product. So if you have a cassette and you have a boarded cassette, and those boards come in a particular multiple of sizes from a manufacturer, you might look at setting your standard types of the cassette based upon those board sizes, so you don't have to have offcuts and waste, for example. If you're precasting an element and you have let's say you formed a mold and you're precasting a panel in a mold or a beam in a mold, and you've built a shuttering bed to precast a beam, maybe you only have one profile, so you only have to have one type of shuttering bed, but maybe you have multiple lengths and you just kind of move the blocks at the end of that bed in and out to create different lengths, and it means that you can pour different lengths of a beam using the same shuttering bed, and you can get very controlled variation but still standardization at the same time. And then complex parts of a building, also you kind of want to concentrate the complexity. So we would try and design like bespoke bracketry, for example, that is maybe has a little bit of a higher fabrication requirement, and maybe there's some elements of a building, of a system, that are designed for performance that need to be procured from a fairly limited pool of suppliers. But we try and really make sure that is as small a part of the overall building as possible, and the majority of the works can be delivered from the broadest possible supply chain. This enables automation as well, right? Because everything I'm talking about in terms of particular types of connection details, particular numbers of types of a product, particular variations in length or width or overall size, can all be preset as rules. And these rules can be automated through scripting, so that from a modeling perspective, we can apply those rules about those different typologies into it all and allow the design to be developed using as much automation and as much efficiency as possible.
Right. You talk about the complexity of building. You even went into detail of how you look at how some of the rooms should be standardized. Talking about beds and by adjusting certain lengths, and therefore you can have a variety of different variables in the modules. So at the inception of the design, does the DfMA come in at the very beginning during the design process, or is it something that is already confirmed with the design intent and then it's handed over to you, where you then start to break up where you need to do it as a modular standards, like for example your floors, your beams, your columns, and so that you know exactly where you are breaking up the pieces? Do you do this after the design intent, or do you do it simultaneously during the design processes?
In my ideal world, DfMA should be thought about from the very beginning of the project, even before there is a project, really. And it's not necessarily meaning that you have to lock yourself into one construction solution, but just applying some common sense to standardizing and optimizing functional requirements of spaces around the type of construction solutions that are available from the market will push a project a long way towards a DfMA solution. So sometimes we do get involved at a very early stage, or even before there is a project, we come on board to work with clients. And our very early stage works at a kind of strategic point of a project are often really focused around what we would call a briefing exercise. So this is working through client functional requirements and representing them digitally, modeling them, analyzing them, testing the kind of challenges inherent within them, trying to find as much standardization as we can between them, looking for opportunities, looking at adjacencies, looking at finishes and fit out requirements, looking at all these kind of things, and trying to fix as much of that as we can, as early as we can. So we've worked a lot in hospitals and healthcare. So for hospital clients, we found that this type of what you would call a clinical planning exercise, it's really important to delivering a successful project at the end of the day. So the more you can do really early on in defining what those requirements are and how and optimizing and finessing them to suit a constructible solution, the better an outcome you're going to get on the project. And we found that healthcare projects that we looked at for our clients historically had lots of rework after construction. So a project is completed and then there's a lot of retrofitting and reworking and changes that are required to reflect clinical needs of users who haven't really been engaged in the design process maybe as well as they could have done. So our healthcare design approach is really kind of almost designing from the inside out. So we would look at specific rooms one by one, work with clinical users, so doctors, nurses, technicians, and understand at an ergonomic kind of level how these people need to interact with these spaces. And then we look at adjacencies and how departments and wards need to be configured as well as they can, and what the requirements are for kind of security and lines of sight to make these wards work as efficiently as possible. An efficient ward means less OPEX as well, because, for example, if you have fewer nurse call stations because you have good lines of sight, you save yourself on nurses effectively. You need less manpower to operate a facility, which is a great benefit. Once we've designed this, like at a briefing level, how rooms need to work, how adjacencies need to work, and how wards need to work, you start to build up a whole department picture of a hospital that can almost start to be considered to be a building in a way. We've defined spatial requirements, spans, clear spans, heights, loadings, vibration criteria, all these kind of things that can be put into an engineering model and analyzed. And this starts to tell us what the construction solution needs to be. So what kind of floor build-ups we need, for example, what kind of structural elements we need to complete those spans, and how you would achieve those spans in the most structurally efficient way. What the requirements are in terms of aesthetics then starts to lead some finishes decisions, and also for robustness of internal finishes and things like that. External planning needs start to dictate what the envelope looks like and how the massing works. And we can start to kind of build all of these criteria into our model using design automation as much as we can, and start to hone in on an overall solution for a project that has architectural quality but also functional performance at its heart. And so for us, that's a really good way of designing, to start at the very early stages at almost a strategic level, at a briefing level, and start to consider DfMA from the very earliest stages to deliver the best overall result. Now, at any stage in a project, DfMA can be considered. I would say it's never too late, but the best benefits always come very early on. That doesn't have to be with us. It can be with any design team that has an understanding of DfMA, but it is something that can deliver a lot of benefits to a project.
And you mentioned that digital modeling is that will come into play when you're working with DfMA. So when it comes to digital tools, do you primarily use BIM? And if you do use BIM, does computational design come into play to help you with your, your standardization so that you can increase productivity in terms of the modeling and all that? Do you do that?
So we were super early adopters of BIM, I would say. In Bryden Wood, we really saw the opportunities that BIM afforded us quite early on, and we kind of jumped into it very enthusiastically. And BIM is quite a transformational technology for our industry. A lot of people see BIM as being a fancy way of doing a 3D model, and for me, the geometric qualities of BIM that you can model in 3 dimensions instead of a 2-dimensional drawing is good, but it's not the only aspect of BIM, and maybe not even the most important aspect of BIM. The fact that BIM is more, CAD is about designing with geometry, it's about designing with lines and shapes, and BIM is about designing with data. And the most powerful aspect of BIM is the data that sits inside a BIM model, the parametric content of BIM. And the fact that BIM is parametric, that BIM responds to information and rule sets, means that it becomes quite powerful in terms of analyzing, interrogating, and evaluating models and design decisions. So we can start to overlay scripts that allow us to automate large parts of our design process through manipulating data in BIM. We can exchange information between different softwares and different users quite fluidly through BIM and information exchange protocols that we build into our BIM execution plans. We can work in our BIM model to test and iterate and evaluate different construction solutions to find the best performing ones in terms of time, cost, labor requirements, embodied carbon, whatever it may be. BIM can be extremely powerful, and I feel like for a lot of people out there in the industry, the real use cases and the benefits of BIM are only just beginning to become realized. So for us, BIM is a really transformational technology in the construction industry. It feels like in the construction industry, we have this huge challenge today. So climate change is this phenomenal challenge, and that it plays such a large role in global carbon emissions, such a large role in global environmental impacts. So much construction waste ends up in landfills, so much energy is emitted during construction processes. So we have this huge challenge, but we also have this big opportunity that we start to see the digital capability emerging to really understand what the impacts are of our design decisions and how to mitigate those impacts. And that's really enabled by BIM. So we have a digital capability. It's evolving really quickly. So what we can do today is far beyond what we could do a few years ago. What we can do in a few years' time is far beyond what we can do today. So for me, it's always exciting. And look, I'm actually, because my role was mainly leading a team, so I'm not really kind of day to day on the tools as much as I should be anymore. But what the guys and what the people in my office can do is extraordinary and really evolving all the time, very, very quickly now, which is great to see. People are coming through universities with capabilities that go beyond what anybody in our industry was doing even a few years ago, and we're finding that the graduates are bringing some really fresh ideas from what they're learning at school, and people are coming into the industry who are digitally native and want to work in this way, and they've kind of been kind of brought up in the digital environment to an extent, and really want to bring that capability into construction. So I think we're going to see a big step change in the way that buildings and design is delivered over the next years as this becomes much more ingrained. Now, all of this digital capability means that we're also expanding our teams beyond maybe what would be the conventional roles for an architectural engineering company. So we have people in Bryden Wood now who we call creative technologists, who don't even necessarily come from an architectural background, although some of them do. These are programmers, coders, data analysts, like full stack developers and front end developers and user interface developers, designers and things like this, who are helping us maybe move beyond BIM in a lot of ways and consider a whole digital and data ecosystem and not just a BIM methodology, developing our own apps, our own custom tools to help clients interact with their projects and their own models in new and exciting ways all the time. So what we're doing in Bryden Wood, I'm always excited to see it, because it's always something new that I never encountered before, and I feel like we're really at the forefront of this change. But there are others out there in the industry too who are also driving some really exciting transformations at the moment.
Would you say that this kind of digital transformation, optimization with the construction industry is a kind of like a tagline for as a driving principle at Bryden Wood, that you manifest in your daily workflow? Is that something that that you work toward this goal with? Is that something that you do at Bryden Wood?
So I would say at Bryden Wood, we're digital evangelists. Don't get me wrong. We're really passionate about our capability in using digital tools and what we're capable of achieving, working in a digital ecosystem. But I wouldn't say it's a driving principle. Our driving principle is design to value in Bryden Wood. So what we're always trying to do is deliver the best possible outcomes for our clients, achieving their functional requirements and their project needs in the most efficient and productive and successful way. And so our digital capability is a tool for us to achieve that, basically. So we use digital technologies to help us in our quest to deliver better value buildings and better value infrastructure for our clients. But the digital technologies are only a tool. It's not an end goal in itself. It's just the tool that we use to achieve the end goal. And so any digital strategy should be based on benefits and use cases. And those use cases should be really understood. There's no point developing a fancy digital model if you have no use for it. We're always focused on what those benefits and what those uses are going to be to achieve our driving goals.
And you mentioned earlier on that at Bryden Wood, you have people coming from graduating from uni with different backgrounds, and not necessarily from the built environment. So with that, and you also talked about being digital evangelist. So for the next generation, how do you actually attract this next generation to join us with the built environment to make it, with all the digital tools that's available now, how can we attract more, younger folks, that are graduating into the built environment?
I don't know, it's such a big question, but I just know from experience that I guess some years ago we were losing people, like a lot of companies in AEC, like losing people to and they're saying, okay, I think construction's boring and old fashioned, and I want to go and work for a tech company, or I want to go and work for a startup, and I want to go and do something, and I want to be a disruptor, and I want to go and do something cool and exciting, right? And so what we're trying to do in Bryden Wood, and I think what we're succeeding in doing is trying to show people that our industry is exciting. And we're not a startup, but we work as a startup in some ways in the type of work that we're doing, pushing the envelope. And we're not, and we like to, I hate the term disruptor in a lot of ways, but we're try and disrupt old conventional processes where we see better ways of doing things. We're also trying to build on the capability and experience and expertise that we have so far, but we're also trying to look for the future and the new exciting applications of tools and technologies. So this approach to construction, I think, is really exciting, and I think that the work that we do at Bryden Wood is really exciting. And there's others out there in the industry who are also doing really cool, exciting stuff in construction. And I think the more and more the general public becomes aware of the type of innovation that's happening within construction today, the more enthusiasm and excitement there's going to be at joining the industry. So I think for graduates, the construction sector is a great place of opportunity. It's one of the, as I said before, the scale of challenge from an environmental perspective that sits in the construction industry, from a carbon reduction and a sustainability perspective, and from an efficiency and productivity perspective, and also in terms of delivering value for customers, because construction often delivers quite poor value. Let's not forget, construction can often be very expensive, wasteful, and inefficient. So there's huge opportunities here. Construction is quite, I would say, backwards in terms of digital tools compared to some other industries. So manufacturing and technology industries are really advanced in the way that they use digital, and construction is quite kind of, I think, in its infancy in a lot of ways. So there's opportunities there. And I think opportunities mean an exciting chance to change things for the better, and that's what we're really trying to do. So we are attracting exciting candidates, and we have people coming into Bryden Wood from all sorts of roles and backgrounds who see construction as a field where they can really do something cool and exciting and exert positive change.
And here's another big question. What do you see the future of the construction industry to be? Given the context that we are at now, we have all the available digital tools. We have graduates, that is, so informed within, especially when you talk about you have coders, you have amazing BIM computational designers in your office. You're doing DfMA. We have all sorts of things that's happening at once. What do you see for the future of the construction? How it's going to be evolving towards to?
The future of construction, I think, is something that's much more collaborative, where different parties, designers, builders, suppliers, fabricators, clients, government, are all innovating and collaborating together digitally as well, and transparently, and kind of sharing knowledge and ideas and new innovative approaches in an open and transparent kind of way to achieve better outcomes. The construction industry of the future is more low risk, so working as designers to design out risks and challenges and improve project certainty and outcomes. The construction industry is better value, with less waste and efficiency, and higher productivity across the board. The construction industry is more sustainable, also with less waste, but also with a much clearer view of the true embodied carbon that sits in buildings. And the construction industry is also more reusable and repurposable, adaptable and flexible to suit the different changing needs of consumers and customers and the general public over time. And all of this is enabled by digital tools. All of this is enabled by a DfMA approach and a platform approach to construction. We want to deliver better outcomes for society as a whole, and there's so much opportunity in construction to do that.
Yeah, totally agree with that. That outlook is definitely look very promising for all of us, with the kind of optimization that we can have the built environment. And
it's an optimistic outlook, sure, but I feel like I got to be optimistic because I think the alternative it doesn't bear thinking about. So I'm really kind of focused on the positive change rather than the status quo, because I think we need to be better as an industry. So let's all look for those opportunities and work to exert that positive change.
Yeah, you're right. I think we have to be positive, otherwise it will impede our creativity of finding solutions to the problems that we face in construction and in the built environment. I think it's always time passes really fast whenever we have such an enjoyable session. It's coming to an hour. I think you've given a lot of clarity as to what DfMA is all about, what P-DfMA that Bryden is doing. And we are definitely very hopeful with the outlook of how the built environment would look like in the future. And I would like to.
I just want to say that obviously we can only cover a small amount in such a short time, and really just scraping the surface of some of these topics. There's lots of literature available on the Bryden Wood website, and lots of blogs. We have our own podcast, our own thought leadership on the topic. We've published several white papers on the platform approach to DfMA, which are freely available to the public. We also have a book published by Reba Books called Design to Value, which goes into a lot of detail on some of our thinking. And also feel free to reach out to us as a company for more clarity. The Forge, the platform project I mentioned in the UK, has been widely published. And if you search for the Forge London on Google, you'll find a lot of information about it. And there's also information on our website. And we're always updating and posting new content, so do keep in touch.
Yep, to our audiences, if you are interested in DfMA and want to know more in detail, please visit the Bryden Wood's website, which we will add into our links when we post our podcast onto YouTube and to Spotify as well. And I'd like to take this opportunity to thank Adam for taking his time to explain to us and join our session. Thank you so much, Adam, for this wonderful session.
Thanks, Chris. Great to be here.
Thank you. I'll see you. Bye.
Thank you.
Hi everyone, thanks for joining us on the session on Digitalk with Bimulus. We hope you have gained some insights from the episode and hope you could follow us in our next episode again. Thank you and goodbye.